Okay, let's talk about primitive data types. So, first of all, what exactly is a primitive data type? Well, here is the Wikipedia definition. A basic type is a data type provided by a programming language as a basic building block. Essentially what this means is all programming languages come with basic data types that are used by programmers for just about any kind of functionality that they're building. It would be impossible to program anything without them. So in terms of TypeScript, those would include data types such as Booleans, which are true or false values. We also have numbers. They can be decimals, floating point numbers, hexadecimals, others. We have strings, which are ASCII characters that are enclosed in between single or double quotes. We have arrays. They can be number arrays, string arrays. We also have some other basic types that I will get into. So let's actually go ahead and jump into a code editor and talk about basic types in more detail. So first let's open up our terminal and create a folder for ourselves. Let's call it basic data types, and we can cd right into it. Okay, and then just to get us started, let's also create an empty TypeScript file. Let's call it basic types.ts. Alright, and now from within here what we can do is we can launch VS Code from the terminal directly. So just type in code space dot /. Okay, and so as I mentioned in my introduction video, TypeScript gets its name from the fact that its objects are type annotated. This means that you can declare your variables and functions to be of a certain type. This ensures that data is kept more secure and logical, especially when working in large-scale applications where you have a ton of code where you could potentially pass some unintended data from one object to another. So this is one of the ways that TypeScript just gives you that extra layer of security. Alright, let's open up our file here, our empty file. And the first thing that I will want to show you are Boolean and number types. Okay, but before we do that, let's also just bring up our terminal, and this is the integrated terminal that you can bring up inside of VS Code. It gives you that option. So basically you're running your terminal or command prompt from within VS Code. So this just kind of gives you, a more of a streamlined way of working on your project. So you don't have to shuffle from application to application. Okay, let's start having some fun and jump into Booleans. So the first thing we'll do is we'll go ahead and declare a Boolean here with the keyword let, and let's name it past exam. Okay, and then we will annotate it with the Boolean data type, and then we will initialize it to true. Alright, so as I mentioned at the beginning of the video, a Boolean can only be either a true or a false value. So this is actually where TypeScript beauty shows, okay, because we will not be able to reassign this to any other data type but that of Boolean. So for example, if we try to reassign it to an integer, it'll give us an error here. So as you can see, we have this little red squiggly line. If we hover over it, it'll say type 10, which is an integer, is not assignable to type Boolean. Okay, so and again, you'll get the same message if you try to reassign it to an array or a string or anything else that isn't a Boolean. Okay, so let's just go ahead and make this false, which is perfectly okay because it is a Boolean value. So this is just a real cool feature in TypeScript. It gives you that extra layer of protection. Okay, so let's go ahead and save this file here, and then inside of our integrated terminal down here, let's compile our basic types ts file. Okay, and let's take a look at the differences between our TypeScript and JavaScript. So the first thing we'll notice here is the var keyword. The reason that the compiler changed let to var is because it compiled our TypeScript code into an ECMAScript version 5 or below, which in ECMAScript version 5 you actually didn't have let or const, you only had var when declaring variables. Okay, now more on this later. But the thing that's really interesting here is that this past exam variable, it doesn't have a type. In JavaScript, types are inferred. So here in this case, it's inferred that past exam is a Boolean just because it was set to true. And you know, then it was reassigned to false, which is still a Boolean. But the thing is that in JavaScript you can actually reassign this to any kind of a data type. So past exam can be reassigned to a string, okay, which is fine. It doesn't give you an error, okay. It can be it can also be reassigned to an integer, which is also fine, right? So you know, like I said before, TypeScript, just because of the fact that it annotates your objects with a type, it just you know, it gives you that extra layer of protection that you otherwise would not have with a JavaScript. Okay, so let me go ahead and close this. I'm not gonna save it. And the other thing that I wanted to show you is that if you are working inside of Visual Studio Code, after you compile your TypeScript, you might actually get this weird message that says cannot redeclare block scope variables such and such. What this means is Visual Studio Code thinks that both your TypeScript file and your JavaScript file are all a part of one file, that they're all a part of the same global scope. Okay, now to fix this, what you have to do is you have to create a tsconfig file inside of your directory. So it's a TypeScript config.json file, and JSON stands for JavaScript Object Notation. We might get into that later, I'm not sure. But basically what this does is that it tells VS Code that this directory is just a project essentially, and that all the files should be treated as different entities. Okay, so now the message goes away. Okay, so moving right along here, let's go ahead and talk about numbers. All right, so in TypeScript you can actually have two different types of numbers. You have your classical numbers such as integers or floating point numbers. And then you have your number literals, things like binaries or hexadecimals. So let me go ahead and give you an example of each. So let's start with just making a couple of numbers here. So let's go ahead and initialize our integer first. So let's make an integer. Let integer of type number be equal to the number 25. And let's do the same with a floating number. And we will set this to, let's say, 66.77. And again, these are kind of your classical numbers. Nothing new, is just your decimal here, and then you have your floating point number as well. Okay. Now what we can do is we can also declare a binary, which is a number literal here. And the way that you would declare a number literal, you would have a prefix in front of what the actual number is, whether it's a binary, hexadecimal, or octal. So in this case, if it's a binary, the prefix would be 0B. And notice B, you know, the letter B is actually a string. It's not a number. But the 0B prefix, it lets the compiler know that this in fact is a binary number. Okay, so and then you would just follow it with, you know, whatever the number is. So in this case, it's 1101 in binary form, which in decimal form is the number 13. Okay, and it's similar with a hexadecimal number. Okay. The prefix for a hex would be 0x. So the 0x, x is for hexadecimal, and then you just follow it with whatever the number is. So AC3 is the equivalent of 2,755 in decimal form. And let's go ahead and make an octal number as well. And the prefix for an octal is 0O. Okay, so the O stands for octal, and then you just follow it with whatever the number is. So let's say 1067 in octal form is the same as 567 in decimal form. Okay, so these are all legit numbers in TypeScript, both your classical numbers and your number literals. Okay. So we can actually play with all this stuff too. Let's go ahead and multiply our classical numbers first. So we'll make another variable here. We'll call it mult, and it'll be of type number. And let's say it's floating times 3. So we're simply just multiplying this number times 3. And let's make another variable here. Let's call it mult literals, and as you might have guessed, this will simply multiply our literal numbers here. So let's say we are multiplying our binary times our octal. Okay, and that should be okay for now. Let's see what this prints out. So to print this out, or just print anything out in console, what you have to do is you have to invoke the console.log function. Okay, just like that, and pass in, whatever it is that you're trying to print. In this case, let's print out our hexadecimal. So this guy here, and let's also print out our mult and our mult literals. Perfect. So what we can do here is we save this TypeScript file. And now what we have to do is we have to compile it to or into our JavaScript. Okay, and normally, well, first let's actually see what it says first, like what it compiled into. So as we expected, it changed the let into vars, just like before, and it seems like the only thing that kept its literal value was the hexadecimal. The binary number, it compiled into a decimal form, and so did the octal as well. Okay, and I think the reason for this is because ECMAScript version 5, it didn't have the number literal representation for binaries or octal numbers. Okay, and everything else is the same essentially. Okay, now if you didn't have node, what you would have to do here to print these things out, what you would have to do is have an HTML file and then link this JavaScript file into that HTML, open the HTML file in a browser, and then inside of the browser, inside of the browser tools, you would have to go into console, and then you would see what it printed out, right? So it's kind of a tedious thing, which there's like a lot of overhead here. Node actually cancels the need for any of this. So because of the fact that Node is a runtime JavaScript environment, it can also just kind of run your JavaScript files, right? So in this case, if we just if we go ahead and inside of our terminal we type in node and then pass in our basic types JavaScript file, it'll go ahead and actually run it. So in this case, it printed out our hexadecimal value, which again, as expected, in decimal form is 2,755. It also printed out our mult, which again, it's our floating number times 3, so it's 66.77 times 3 comes out to 200.31. And then it also printed out our mult literals, which in our case is our binary times our octal, so it's 13 times 567 comes out to 7,371. Okay, so yeah, so that's pretty much numbers. The other thing I wanted to show you though was the type of function. So let's say that you're trying to find out what type some variable is. So let's say like you're getting you have a function, or you have something that you have a variable that's getting passed in, and you're just trying to make sure that that variable is of a certain type. The function that you would use for that, and this is just a plain old JavaScript function, is the type of function. So you just invoke the type of, and then you pass in whatever it is that you're trying to check its type, right? Let's go ahead and see what our hexadecimal variable, what type this variable is. Okay. Now to have this printed out, we just go ahead and just pass this into our console.log function here. So what this will do is that this will just simply print out, like whatever our type of function returns. So it checks what type that our hexadecimal variable is, and then it returns that type, and then our console log function will just print it out essentially. Alright, so let's go ahead and save our file, compile it again, and let's see if our basic types compiled correctly, which it did. It seems like it has this new line of code in it. And now if we run our node again, we see our values printed, and also we see our number type printed from this line of code here. So it all works as expected. And again, this type of is just a nifty little function if you're trying to see what type of data a variable is just a quick way of doing it. Okay, so let's get into strings. Strings are a very fun data type to play with because of the fact that they contain an array-like structure of alphanumerical characters. Hence, they have a lot of functionality that also applies to arrays. Now, in JavaScript, there's a multitude of these functions, giving you the ability to play around with them in many ways. So let's jump right into it. Let me first comment this out. And by the way, this code will be on my GitHub account, and I'll embed the link below this video. So, there's no need for copying what you see on the screen or anything, okay? So, to declare a string, which you do just like with numbers or booleans, you start with let, and then you give it a name. So let's make an animal here. Then you annotate it with the type string, and then you give it some value. It'll be a horse, let's say. Okay, and then let's console log our horse. Okay, file save, and now we can compile it. And then we run our compiled file with node, and there it is, a horse. Now, just like with numbers, we can obviously reinitialize it to something else. So let's say an animal is now a turtle. So it went through some metamorphosis, and it's now a horse is a turtle. I don't think that really happens in nature, but hey, whatever. Oh, and by the way, you can declare your strings with either the single quote or a double quote. Okay, both are fine. Okay, so let's save it again, and we run the compiler. Okay, and then node basic types.js, and there it is. Now we have a turtle. Now, running the compiler every time that we want to see what changes we've made is quite tedious. So the TypeScript compiler actually has a handy little function for this, but it's best run with a different terminal window. Okay, so let's go ahead and open up a new terminal window here. So let's go to our top menu, terminal, new terminal. Okay, and now there's, you can see in this drop down here that we in fact have two terminal windows. And in the new terminal window, let's type in TSC like always, but now we will flag it with a -W, okay, which stands for watch. All right. So now what's happening here is that when we run this, it's watching every change that we make. Well, not every change, but every time we save, it'll recompile it again. Okay. So this is just a nice little handy feature. Okay, so now it started the compilation in watch mode, and it's watching for file changes. Okay, so let's get into something more interesting here. Let's get into template strings. Okay, so what a template string is, think of it as a kind of a visual representation of whatever it is that you have on the screen. Okay. And this will become easier to visualize once we actually get into it. So let's get into it. Okay, so let's go ahead and create a product here. Okay, and it'll be, let's say it'll be t-shirts. Okay, so we're selling t-shirts. And we'll have a number sold. And obviously this will be a number. And let's say we sold 100 of them today. All right. And now let's say that we would want to have some kind of a report type string that says, hey, we're selling a bunch of products. They can be t-shirts, or they can be, jeans, they can be hats, they can be whatever, right? Like you would just want a nice little template that would be able to kind of capture the different variables, the different products that you can sell, and you would also want it to capture the different numbers of those products sold, right? So, obviously you'll presumably sell a different number of t-shirts as you will jeans, right? So anyway, let's go ahead and create a template string here. So I'm just going to name it template string because I'm not really that creative with names. And this template string will be a string. And now the way that you let the compiler know that it's a string is you actually start off with a backtick. Okay, so these are our backticks here. I think they're also known as back quotes. Okay, and let's say our template will say something like this: we specialize in selling some product. And the way that we would actually try to embed this product is with a thing known as embedded expressions. Okay, so what an embedded expression is you effectively kind of have this little holder value inside of your template string that will, at compile time, it'll actually read whatever the expression is that you're putting in there. Okay. And to let the compiler know that it's an expression, you simply start off with the $sign and then brackets. Okay, so this little combination lets the compiler know that whatever is inside of it is an expression. So now all we have to do is we just simply pop our little product in here. Okay, and there it is. Now. Remember how I said that a template string is sort of a visual representation of what you see on the screen is what you get. So let's actually, let me show you what I mean by this. For example, I can go ahead and then just kind of have like a blank line, right? So obviously if this were a string, it would give you a compile error. But because of the fact that it's a template string, this is actually okay. What the compiler sees here, it just kind of sees this blank line as just like a blank line. You're sort of starting a new paragraph almost, in that way. So it's a very handy feature. And so anyway, let's say that this week we sold, and again we will go ahead and embed another expression in here. So this will be number sold, and we'll finish off our string here with this. All right. And let's go ahead and console log our template string here, and let's see what we get. So save, and now because of the fact that if we look in our new terminal window here, it recompiled it again, right? So what we can do is let's go back to our original window. We don't have to run the compiler again. All we have to do now is just run node. That's it. See, there it is. We specialize in selling T-shirts. So this T-shirts here, it it came from the product, and then this week we sold 100 of them, and this 100 came from number sold. All right, and notice how there's this blank line, right? So this just came from this. I'm sorry, here, right? And again, the compiler saw that this was just kind of like an empty line. So as you can imagine, template strings are widely used now, especially in web applications, just because of the fact that it's real easy to, not only embed expressions in them, but also just kind of, have this visual representation that you can just easily just kind of pop the whole chunk of characters into some other piece of your application, right? So a lot of web applications are using it. It's just being used way more than your quote-unquote classical strings. Okay, and now the last thing I want to show you with strings are string functions. So as I've said earlier, there are a lot of functions that strings actually have that ship standard with JavaScript. I will obviously not show all of them to you just because that's kind of impossible. Well, I guess it's possible, but that's just a lot of me talking. So let me just kind of show you the top ones, I guess. So first of all, let's comment out the console logs here. Okay, and let's say these are string functions. Okay, so the first function I'll show you is the length function. Okay, now this is important. Everything in JavaScript is an object. Okay, so if you have a variable of type string, that variable is in fact an object of type string. Okay, and every object will have native functions, and length is in fact a native function of the type string. So to get the length of, let's say, product, all you have to do is just invoke that function, and you do that by just typing in a dot or a period, and then you follow it with whatever function you're actually trying to invoke. In this case, it's length. Okay, so this little line of code will actually give you the numerical number of this string of product. Okay, now because of the fact that this will be stored in memory, but it's not going to output anything, what we want to do here is we'll just go ahead and console log this, just so we can see what the number actually is. Okay. All right, and let's save it, and let's run our node here, and there it is, right here, 8, right? So T, which is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so simple enough. That's the length function. All right, next we have the search function. So what the search function does, and let me just comment this. This here is the length function. All right, and now let's search for something in string. Okay, what the search function is you effectively get the index of the first letter of the characters that you're actually trying to search for. So let me demonstrate. Let's go ahead and make a new variable here. Let's call it search string. Okay, and we will assign it to template string dot search, and then we have to put in what we're actually looking for, what we're searching for. Okay, and let's say we're searching for the word selling. All right, so we are saying, okay, search the template string for the word selling. Okay, and there it is. And what will be returned from this into search string will be the index number of the first letter of whatever it is that we're actually looking for, in this case selling. All right, so let's go ahead and console log our search string here. Okay, let's just clear this out. Perfect. And we can save it and run node again. Okay, and it's 17. All right, so the index number of this letter S in the template string here is 17. All right, so let's just count really quick. So we have the 0, because remember indexes start with 0, so the W is a 0 here. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. So S is in fact the 17th index of template string. Okay, so that's search. Next we have slice. Okay, and what slice does is it extracts a part of a string and returns the extracted part in a new string. Okay, so let's say let's slice equal to template string dot slice, and we are slicing, let's say 3 and 8. All right, and let's see what we get from here. So let's console.log slice. Okay, and also I'll comment out these guys here just so we don't get confused. Okay, save node. Okay, and it gives you the this little string here. All right, so but I mean, what is it, right? So what this does is that it starts with the third index. I'm sorry, the third, right? Yeah, the third index, and then it ends at the 8th index. Okay, so in this case we have 0, 1, 2, and then it starts here. It starts with the S, and then it goes to 3, 4, 5, 6, 7, and then it ends at the 8th index number, but it doesn't include the 8th index number. So all you get here is just special. Actually, just special. That's all it is, really, right? Anyways, so that's slice. Then we can also replace a string content here. And the way that you will replace string content is with the replace function. So let's say let replace equal template string dot replace, and we're trying to replace what? We're trying to replace specialize with, I don't know, let's say pride ourselves. Okay, I think that's right. Okay, and let's see what that returns. So let's console.log replace, and let's go ahead and comment this out. Save it, run node on it. Okay. So yeah, so now it's actually it replaced it, and now it says we pride ourselves, instead of we specialize, we pride ourselves in selling t-shirts. Okay, next we have concatenate. Okay, so what this does is that it just simply strings things together. So let's say let word1, and this will be the word, let's say hi. Okay, then we have words2, and word2 will be there. Okay, and now let's have another variable here called greeting, and let's say word1 concat, that's the function. So we're concatenating something with to word1, and what we will do is we will just sort of, first of all, the first thing that will go in here is just a blank space, and then we're gonna put in words2. All right, so effectively what we should get here from greeting is we're stringing together a bunch of things here. We're stringing together hi, and we're stringing together the little blank space here, and then word. So in fact, from greeting, what we should get is hi there with this space. All right, so let's go ahead and console.log our greeting. Okay, save it, run it. Hi there with the space. Okay, so that's concatenate. And last but not least, we will also have the upper and lower case functions. Okay. So let's say console.log. Oh yeah, wait. First, we actually need, a variable here. So let's say let some text equal, I don't know, hi there. And now we can capitalize it or make it all lowercase. Okay, so first let's go ahead and capitalize it here. So some text dot to uppercase. Okay, and then we can do the same thing with to lowercase. Perfect. Let's save it. Let me just comment out the greeting here. Save it, run node on it, and there it is. We have a capitalized hi there, and then all lowercase hi there as well. So that's the wonderful world of strings. I would suggest that you would get into it and just start sort of playing around with it. They're a lot of fun, and there's a lot of things to actually do with them. In terms of a data type that you can just kind of play around with, I think that they're like the most playable. Okay, so that's strings, and that concludes part 1 of basic types. I hope you enjoyed the video. If you did, please subscribe and like it, and comment below. I will see you in the second part of basic types, when we will get into arrays and other types as well. So thanks for watching, and I'll see you next time.